These numbers on the right here, on these little quizzes we've been going over, tell me basically how many people have done them. Is everybody okay with this stuff? Because this tells me only very few people are practicing these. You guys are comfortable with this stuff? Are you getting practice from Ellie? Ellie? A lot of people come visit you? No? Well, I'll say again that test one will have one or two out of each one of these categories. So if you want to be ready for the test, just practice these. And if you can't do them, then you definitely need some help. So I guess I'll just go on with these, but it just makes me nervous that everybody's not doing them. Where were we? Oh, I know what we're going to do next. And this these. So metric to metric conversions are almost always, we're almost always working in length or mass for these types of calculations or volume. So and we usually stay between mega and nano, so I'll put those over here. Mega. So those are most typical units from that list. There's some above there that go to, they do up there. I skipped one, skipped two. So giga, tera, peta, exa, and then the really tiny ones, pico, femto, atto. We don't tend to use those very much. There's a selection of them from that list. This is basically what these prefixes mean. That chart is a little confusing looking at these because it doesn't have what you're used to seeing here. You'll either see megameters, kilometers, decimeters, centimeters, or you might see megaliters or kiloliters or deciliters or centiliters, milliliters. So without that unit there, it's just a little confusing. But basically what you're going to need from this is, most charts don't include the base unit either. I should do this to be consistent. That's 10 to the 0, which is equals 1. And that's where I would write, if this was meters, I would put, let's get messy. So books don't always include this spot, but there is a spot there. So this was 10 to the 6, 10 to the 3, 1, 10 to the negative 1, 10 to the negative 2. So this is where the 10 to the 1, 0 would be. All right, what do I wanted to explain here? If you had to, I'll just throw a question at you. Let's see. So this is a metric to metric conversion, going from decimeters to micrometers. It tends to be an easier question when you're going to the base unit. Actually, let me do that. Let's start with meters. So now I'm having to come up with the conversion between the base unit and which one, micro. So I'm saying I have 17.34 meters. What is that in micrometers? You start for M for meters, I always put it over 1. All right, so we need a relationship between the base unit and the micro. This 10 to the negative 6 isn't really referring to micro, it's referring to what the base unit is. So this is micrometers listed here in the list, but this is telling you one micrometer is 10 to the negative 6 meters. This column here is meters, in this case, because I'm dealing in meters. So that's what this number means. It really means to the base unit. The number that's on this list you see here on slide 6. Of course, you can write this in the expanded form with all the zeros. Let me play with this. Am I still on camera? Sorry. Yeah, I've got space over here. So what I mean here is 1 meter, the base unit, equals, no, I just did it wrong. One micrometer equals 10 to the negative 9 meters. You see how I got that? I told you I'd give you that list for a test. You don't have to memorize it. Just be able to come up with the conversion factor off of it. That's what you're going to need it for. And I mentioned the other day that that's just written as an equality, but you could also write it as 10 to the negative 9 meters is 1 micrometer. Oh yeah, 10 to the negative 6. Did I make that mistake over there? Yes. 9 is nano. Negative 6. There. Now do you see how I got that without a mistake? Of course, this is how you're going to use it in a calculation. And also, I'm going to use this was micro, so I've got to use micro. The Greek letter mu for micro. Okay, so we're trying to get from meters to micrometers. So I need to take this and flip it over so it looks like this. So the rest of it is just the math that goes along with it. Let me point out, though, that 1 micrometer those do actually equal each other. You see that? My brain thinks like this. Every chart I ever see in any textbook is like this one. This is how I think. I think of a micrometer as, I think of a meter being made up of this many micrometers. But either one of these will work in the conversion, however you want to do it. I could also write the zeros out. But, so to finish this out, the meters cancel, the one doesn't do anything. Oh, yeah, I want to point out again, this is 4 significant figures. That's exact though, we can ignore that one. This is metric to metric conversion, so both the top and the bottom are exact. So this is the only source of significant figures for us to pay attention to. So we do need 4 significant figures. If you do the math this way, the first thing I'm going to have to do is bring that 10 to the negative 6 up to the top. But when you take it from the bottom and bring it to the top, you just change the sign. So that's how I got this up here. Micrometers is all that was left of my units. I could bother to put this in scientific notation, standard scientific notation. It's already in scientific notation. But unless you're specifically asked to do that, you don't have to. So this could have, instead of being meters, it could have been liters, and it could have been liters, meters. Which one am I missing? Length, volume, and mass could have been grams. So solving problems like this involves being able to find the base unit. I mean, being able to find the conversion factor. So metric to metric, both are exact. When it's standard or English units, I told you last time that the ones are exact and the non-ones in these relationships are where we get your significant figures. So I'll give you all of those on a test. You'll have to memorize them.
For the scientific notation on that, is because usually when I see it, it's like it's pulling something in the ones place. Is there a reason why it's in the tens place, or like is that I don't know?
What, the decimal?
Yes, sir.
I just reported some random measurement I made up.
Okay.
And it's 17.34 meters. I guess I could have put this in scientific notation, but scientists don't always put everything in scientific notation, only when it's really sensitive. So I just made that up. So then when I calculated this through to make it micrometers, I just left it this way. But if this problem continued and said, put your answer in standard scientific notation, then I'd take it another step to put it in scientific notation.
Okay. So that's not that's not standard.
No, that's not standard.
Okay.
So, I don't want to move the camera. I wish I could get the screen and the board on the camera, but so I have now these scientific notation, metric conversion factors. So you'll want to practice this. These answer keys are more like the way I think, like this, relationships like this. But let me show you a couple of twists. So there's the base unit, and then there's relating the base unit to something down here, or relating the base unit to something up here. Those tend to be very easy because you've got that number right there. I mean, I literally pulled this out of this list. For instance, so relating any of these works exactly the same way. It's going to be this many base unit. Let's just use the word meters so it's not confusing. this many meters in 1 micrometer. It's this many meters in 1 centimeter. But if you go up here, it's easy again. There are this many meters in 1 kilometer. Get messy up here. There are this many meters in 1 megameter. So, relating that this time. Relating kilometers to meters. But if you're doing, say, relating centimeters to millimeters, it probably helps to understand this more conceptually. But there's only 1 order of magnitude difference between the base unit and deci. And same with these. These are all only 1 away from each other. So if I wanted to quickly come up with centimeters to millimeters, I would just say 10. That's just easier to deal with in a math problem instead of putting powers of 10 all over the place. But the powers of 10 will work. If you zoned in on doing it that way, just keep doing it like that. But this is how my brain thinks. That's just because I've studied this stuff for so long. I relate them a little more directly. The weirdest twist is when you're trying to relate something from up here to something down here. I like to do this one. Let's say I need to get from kilo to, let's do, I was trying to get from kilo to nano. I will first write down this relationship. And then you would just use both of those together as a conversion factor. But if you get better at this, you can start doing things like the meters cancel. That one doesn't do anything, that one doesn't do anything. I'm left with kilometers over nanometers. That's those. I've got 10 to the 9, negative 9 on top. 10 to the 3 on low. You could use that as your conversion factor. You could play with it a little more though. If you wanted to get rid of one of these powers of 10 and just turn it into a 1, the 10 to the 3, if you move it to the top, you're essentially then multiplying that, or negative 3. If I move it to the top, I have to change the sign. 10 to the 3. Yeah, that's right. And then this ends up being 10 to 12. So you could also do that. That would work in your conversion as well. All these do equal each other. Those together equal this. Those together equal this. You could even do this. 1 kilometer is 10 to the 12 meters. That would work as well. So this just takes practice. Practice, you decide what works best for you. There's also I'll leave it at that. So coming up with your metric conversion factor is important, an important skill. And I have in the